Hey, Chapter 2.3, Visualizing Variation in Categorical Variables. Today we're going to focus our attention on methods of displaying the distributions of one or more categorical variables. When visualizing data, we can treat categorical variables in much the same way as numerical variables. We do this by displaying the values, the categories, of the variable and the number of times each value occurs. Let's begin by analyzing a list of data for a sample of cars described in Consumer Reports 1999 New Car Buying Guide. Variables shown below is the type of car, and the categories were large, small, family, SUV, luxury, sports, and upscale. This data set contains the data for 109 cars, but we're only seeing part of the data set here. And so in fact, if we look, we're seeing data for 42 cars. So what does this data set reveal about the types of cars in the data set? Well, it's hard to see or hard to tell at this point. And for one reason, we don't have all of the data. And the second thing, at first glance, it's hard to tell because we've got a list of categories. But we might see one pop out more than the other. So by first glance, I see a lot of luxury cars. Okay, but again, that's hard to determine because we don't have access to the other cars in this data set. Family pops in there a lot as well. Okay, and number 4, just as we saw with numerical variables, it's usually difficult to detect any patterns or key features of a data set containing categorical variables when it is presented as a list of categories. The table below contains the distribution of this data set. Notice that this table lists the types of cars and also the frequencies for each type, how many cars of each type. So we've got our categories over here, and over on the right, we've got our frequencies. So notice the total here gives us 109, so we've got the data for all 109 cars. And now it's much easier to take a look at and see if there are more luxury cars than others. Turns out there isn't. Right? Turns out there's more family cars than any other type of car in that data set. All right, this frequency table gives us much more information about the data than the list of categories did. It tells us how many times each type of car appeared in our data set. But a picture or graph of the distribution can make it even easier for us to see patterns. Following is a bar chart of this distribution. A bar chart or bar graph is a graphical summary for categorical data and shows a bar for each observed category, each type of car. The height of the bar is proportional to the frequency of that category, how many cars there are. So for instance, the family category, we saw in our table that there were 28 cars that fit into that. Notice that the height of the bar confirms this, that there are 28 cars in that category. Okay. All right, so a few notes about these bar charts. Key features. One, each category is represented by a bar. The height of the bar is proportional to the number of times that category occurs in the data set. The width of the bars has no meaning, but is usually consistent from one category to the next. So if we go back up to our bar chart, notice that the category with the most cars, family, has the highest bar. Category with the fewest number of cars has the smallest or shortest bar. Also notice the widths of the bars, that's this measurement here, is the same for all of our categories. Right. Second item, second key feature, one axis, usually the vertical axis, measures the frequency or relative frequency. So right now it's measuring frequency. But if we convert this to a proportion, we'll take family cars as our example. 28 out of 109, which is about 11%. This is called a relative frequency. So in that case, we would relabel our vertical axes as relative frequencies. Okay. All right, back to our list. Third bullet, one axis, usually the horizontal axis, displays the values, categories of the variable. The order that the bars are displayed in doesn't usually matter. Sometimes they're displayed in alphabetical order. Other times they may be sorted from most frequent to least frequent. When the bars are sorted from most frequent to least frequent, then the bar chart is called a Pareto chart. Unlike the histogram, there are gaps between the bars, indicating that there are no observations between categories. In other words, it's not continuous data. Okay, number 6, a pie chart is another graphical summary used to display the distribution of a categorical variable. Following pie chart shows the proportion of cars that belong to each category, the same data that's shown in the previous bar chart. So notice that the family, let's see, is that the one we looked at on the previous page? Oh, let me go back to the previous page. I think I have the wrong percentage here. Yeah, so if you were wondering about that 11% that I wrote down, that was an error. That was actually about 26% of the cars. Okay, so if we go back to our pie chart, probably see how I noticed that. So our family slice is right here. Notice that the legend tells us that this is 25.69% of the cars or of the data set. Okay, so again, a pie chart is just another graphical summary used to display the distribution of a categorical variable. And this pie chart shows the proportion of cars that belong to each category. And so some key features of a pie chart. The pie is sliced into several pieces. Each piece represents a category of the variable. The area of the piece is proportional to the relative frequency of that category. The slices or categories may be labeled with a name and either a count, the frequency, or a percentage, which is called the relative frequency. The counts or relative frequencies may also appear in a key next to the pie chart, and that's seen in the above pie chart. So again, here's our key. These graphs are not used all that often by statisticians, since it's not always clear how much larger or smaller one slice is compared to another slice. Bar charts make these differences easier to see. So for instance, if we go back up to this chart, let's actually go back to the bar chart. Family and small categories, somewhat similar size bars, but we can see that the family bar is higher or taller. Come back to our pie chart, but family and small may not be as easy to tell the difference between their relative sizes. So again, usually a bar chart is preferable. All right, so our last bullet down here, these graphs also make it more difficult to compare the distribution of a variable across two or more different groups, such as comparing American cars and European cars. So imagine if we had this pie chart above and they were just American cars included, we might have another one next to it that did the same categories, but for European cars. All right, so last question. Which graphical summary, the bar chart or the pie chart, do you find easier to use? And which one is it easier to compare the sizes of the categories? So that's somewhat subjective, but hopefully you find that the bar chart is helpful because that's what we're going to be focusing on in most of our other sections.